All right, we're going to start on section 1C. Again, I'm going to preface this by saying that you should read this first on your own. You'll get more out of the recorded lecture if you kind of know where we're moving from and to. Section 1C is about sets and Venn diagrams. A set, such as like the set of the days of the week, has different members in it. The members of this set of the days of the week are Sunday through Saturday. If I want to find the set of the first presidency, the members will be President Monson, President Eyring, and President Uchtdorf. Set notation takes the members and shows that these members are a part of that set by putting a bracket. This bracket you can find on your keyboard. It's right next to the backspace button, just down a row. And the first bracket on this side starts the set. Each member is separated by a comma, and then to end the set, you have another bracket. So my first set, or the set of the days of the week, will be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday, separated by commas, and then closed with a bracket. And the set of the first member, or of the first presidency, the members are President Monson, comma, President Eyring, comma, President Uchtdorf, and your bracket. Let's try a couple more sets. If I'm looking for the set of integers, integers are negative numbers, positive numbers, and 0. To show this, I'm going to kind of go in a progression of -3, -2, -1, 0, 1, 2, 3. Now, because the set of integers goes on for eternity or infinity, I need ... to say it goes on that direction and ... to tell us that it goes on in that direction. The set of letters, I start it with my bracket, A, comma, B, comma, C, comma. Now I could go on and list all the letters, but I don't want to list all 26, so I'm going to put ... and now it ends at Z, and close off the set with a bracket. The ... is called an ellipsis. This means it goes on in one direction or the other, or in between two. Let's go ahead with our next set. Our example, sets of continents on Earth. I have North America, South America, Asia, Antarctica, Africa, and on and on. Close the bracket, and I'm done. The second example, set of Olympic sports. You can go through and add as many as you want, ... close your bracket. The set of whole numbers. Whole numbers do not include negatives. They also don't have fractions, and it starts at 0. So I start my bracket, 0, comma, 1, comma, 2, comma, 3, comma, 4. Now again, this goes on to infinity, so I can't finish this set, and I have to do the ellipsis and give my closing bracket. Now that we've talked about sets, we're going to move on to Venn diagrams. Venn diagrams are named after the inventor John Venn. He invented these as a visual way to describe the relationship between different sets. So I'm going to start with the set of dogs and mammals. Dogs and mammals. Well, a dog is a mammal, so a dog is the subset of mammals. So I first give myself a big box. You can do that by inserting a shape, creating a box, and then inside of it I have mammals, and within mammals I have dogs. I have other animals in there as well, but that shows me the relationship, the visual relationship between mammals and dogs. Now, because this outer circle is mammals, then outside of that are all the other animals that are not mammals. I can also create a Venn diagram instead of inserting shapes by using Insert and use Smart Art, and go over to Relationship and scroll down. I have different options here. A linear Venn diagram you might be able to use for different occasions. I like this one. You can move the basic Venn diagram around to suit your needs. And in our case, they call it a stacked Venn diagram. I'm going to bring it up because I have mammals and dogs, so I'm going to get rid of some of these. I don't need that one. I also don't need that one. I just need two. And it's pretty big, so I'm going to shrink the size down, and we'll bring it down just a little bit. And in here, we're going to put my text, mammals, and right here, dogs. I can go up and increase my font. I can change the style. I can add in, let's go ahead and change the color, make it pretty, and we can change the style to make it look a little 3D. You can format it by giving it an outline. So let's give it a black outline, and I want to change the weight of the outline, be pretty dark or big. There we go. Now, the disadvantage to doing this is that you still need to go through and put your label of what happens outside of the hierarchy right there. So outside of here, if I want to finish up that Venn diagram, I can insert a text box, do a simple text, and this one, the outside would be non-mammals, and come in here. I would like to format my text box. I don't want a border on this one because it's going inside, and I could do some other things. I'm just going to get rid of that so that I can put it inside my Venn diagram. Oops. Bring it in. Oh, it's a little big. So let's change the font. 8. Let's see if that'll be big enough for us. And move it somewhere in there. You can go ahead and format your Venn diagrams however you would like. Okay, let's go ahead to the next one. Now let's find the relationship of sets of dogs and cats. So again, I give myself my box to define these are animals, and then I make my set of dogs, and then I'm going to have a set of cats. In this case, they aren't going to touch. I don't have a subset where one would be inside the other, so this one is considered disjoint. And everything outside of that is going to be, let's move this into here, other pets. All right, now let's move on to our next example, redheads and toddlers. So I have a set of redheads, and you can see I used my Smart Art by inserting. I'm going to show you again. Go to Smart Art, go to Relationship, and this one is a basic Venn. It works really well. You can delete one of the circles if you don't want it. You can use the subset, or you can use a linear Venn diagram, whichever one works best for your examples. And then we can even change it now. If you would like to change, let's see, we can make it like this. We can change some colors, except I like the redheads like that since it was red on that side. Alright, so I have redheads, and some redheads are going to be toddlers, so these are going to overlap. And outside of that, in the Venn diagram, is anyone who's not a toddler and who is not a redhead. Okay, the next one, our fourth example, Democrats and Republicans. Democrats, you are going to either be a Democrat or Republican. Again, these are disjoint, so these two aren't overlapping. There isn't a subset. And outside of those bubbles will be independents and the other political parties. Example 5, Nobel Prize winners and Pulitzer Prize winners. So I have an overlap because one does not mean that you can't have the other, and there might be somebody in the middle who is a prize winner from both categories, and outside of that are people who have not won a Nobel Prize or a Pulitzer Prize. these ones are overlapping. Now, before we go any further, the next sets that I want, or the next couple of sets to do our Venn diagram for are the natural numbers, whole numbers, integers, rational numbers, and real numbers. Natural numbers were the first numbers in the evolution of numbers. They are the counting numbers, the numbers that they needed to trade items. 3 bushels of hay for 1 chicken, or you get the idea. Then, I know it sounds kind of silly, in the evolution of numbers, the whole numbers comes next, and the only thing added to the natural numbers for the whole numbers is the number 0. It took a long time to come up with a placeholder of 0, that nothing is present. So the whole numbers are 0, and then the counting numbers 1, 2, 3, 4. Then the evolution continues for integers, where you start having a subtraction or a negative element. Rational numbers, another name for rational is a fraction. So those are all fraction numbers, or things that can be written as a fraction. So decimals that can be rewritten as a fraction, and even repeating decimals. So 0.333333 repeating is the fraction 1/3, or 0.5 can be written as a fraction of 1/2. Then real numbers, which is all numbers that have been made in the evolution of numbers. These are subsets. So I start with the natural numbers, then I have whole numbers, then integers, and then rational numbers, and then real numbers, and they're each subsetted inside of the one previous. Outside of the real numbers are something called imaginary numbers, and some of you have worked on those. We aren't going to go into that in this class, but yes, those are the imaginary numbers. Okay, Roman numeral 2 are categorical propositions to help, we're going to bring that up, to help decide about the claim on the relationship between the sets. So our first example is all whales are mammals. So I have a subject of whales, the predicate is mammals, and here I have a subset, mammals, and then whales. And it's showing this claim in the relationship, and outside of that are, of course, non-mammals, because everything that's a mammal is inside this part of the Venn diagram. No fish are mammals. Can you see what kind of Venn diagram that will be? Will it be a subset? No, because no fish can be inside the mammal bubble, which means they can't even touch it all. So this one is a disjoint. The no is indicating that these have nothing to do with each other. Some doctors are women. Are these disjoint? No, because some doctors are going to be women, so they overlap at least somewhere. So these ones are overlapping. And we should probably put in a big X right here saying that there is at least one woman who is a doctor. Okay, some teachers are not men. So in this case, we're going to make 2 overlapping. My subject of teachers, predicate, not men. So I have teachers, and let's go ahead and just do men, so that outside of that bubble will be not men or women. So if these are all teachers, and this is all men, overlapping are men in the profession of teaching. Over here, men that are not in this teaching circle are men of any other profession. Because these are all men, over here are all women. And so, or women who are teachers. So these are the women who teach, because they are not in the men bubble and they're in the teacher bubble. So what's out here? Well, if this is teachers and this is men, this must be women who are not teachers, so of other professions. Okay, moving on to the next one. Putting categorical propositions in standard form. So if I have some birds can fly, changing it to some birds are animals who fly. Why is that important? Because when you're making your Venn diagram, you don't just do birds and fly, you do animals who can fly. So here I have my overlapping animals who can fly, or animals who do fly, and birds. So I have animals who can fly in this whole bubble, and that includes any animal that can fly. Bats, bugs, moths. Over here are birds. Right here in the middle are birds who can fly. Outside of that, because they're a bird, but they are not in the flying bubble, that means these are birds who do not fly. Now, down here in the white part, because it's not in the bird category and it's not in the flying category, these are all other non-flying animals. Let's move on to the next one. Elephants never forget. Changing that to no elephants are creatures who forget. Or you can say it, no elephants are forgetting animals. Something to that extent. The no means we have a disjoint relationship. So I have a category of elephants and the category of forgetting creatures, and they don't touch because no elephant will be in the forgetting creatures circle. Outside here I haven't listed it, so let's talk about it. If this is all elephants and these are all forgetting creatures, then out here are anything that is all animals who are not elephants who don't forget, because these are forgetting creatures. So outside of that are all animals who don't forget. Moving on to Roman numeral 3, Venn diagrams of 3 sets, which is where it'll come in handy when you insert. Remember, I'm going to show you once again, just so you remember, smart art, relationship. You can use this one with 3 different sets. So they did a study about teenagers with their employment rates differing between boys and girls, and also looking at their honor student or not honor student. So we have 3 different ideas. Is the teenager male or female? Is the student an honor student or a not honor student? And is the student or teacher or teenager employed or not employed? So I have my 3 different sets: employed, female, and honor student. So up here in employed, notice it is not in the female bubble. So up here in this portion of employed will be all teenagers who are male. So male teenagers who are employed, and also they are not in the honor student set. So this is employed, male, non-honor students. This little overlapping section is females and employed, but not a part of the honor student set. So this is employed females who are not honor students. Here in this portion are females. They are not in the employed bubble or set, and they are also not in the honor student set. So these are just unemployed female non-honor students. This portion right here, let's go into this one. This is still in the female set, but it also now overlaps with the honor student set. These are all female honor students, but it's not in the employed section, so they are all non-employed. Here we have honor students. Are these male or female? Well, if this over here is female, then all of these honor students in this set right here, the visual, is all male. They are honor students, male honor students, but they are not in the employed set, so this is unemployed male honor students. This portion, the overlap, again, I'm not in the female set. I am in the honor student, but I am also in the employed, so these are male, employed honor students. And this tiny section, I didn't label it. I have female honor student who are employed right there in the middle. Outside of all of the sets are going to be all not employed, because this is all employed, so these are non-employed, They are not female because all the females will be in this set. So male students who are not employed and also not an honor student. And if I had numbers from this study, I could plug the numbers in to show where each of these numbers comes from my study. I can put an X in the appropriate place for the following statements. Some honor students, or our boys, are unemployed. So remember, this is the female category, so it can't be in there. I need it to be an honor student, so it needs to be somewhere in this green circle, who are unemployed. If these are all the employed students and I need it to be green, it can't be a female because it's male, and it can't be employed, my X is going to go in here. So I can insert a shape, and I'm just going to go ahead and put an X by using my drawing tool. There we go. It's not a fancy X, but it gets the point across. Here's the answer over here, just for keeping everything continuous. The next one, non-honor student girls are employed. So I want female, so it will be in this set. Non-honor students, so it can't be in the green, so it's going to be somewhere over here, who are employed. There we go, employed females. There's the answer. You can go ahead and make an X with your drawing tool or however you would like to. You can make a text box and get rid of your border and just put in an X and put it where you want it. It's up to you. Okay, Roman numeral 4, more on Venn diagrams. Here is a study that was done, or more of a poll that was done on the mother's smoking status and low birth weight from the babies that were born to these mothers or non-smokers. So I have over here my categories of smoker or non-smoking mother. Then I have low birth weight babies and normal birth weight babies. And I have the numbers for each of those. So let's go ahead and fill in this Venn diagram like I would have done on the previous one if I had had numbers. So over here I have babies born to smoking mothers. Over in this set, babies with low birth weight. So in this one, babies born to smoking mothers are not babies with low birth weight, so I want normal birth weight babies born to smoking mothers. So smoking mothers, I don't want low birth weight, I want normal birth weight. So I would have 132 babies in this set. Now over here, babies with low birth weight, but notice it's not in the set of babies born to smoking mothers. So here, babies with low birth weight. That means a non-smoker with low birth weight, 14. Then the intersection of the two will be babies with low birth weight and babies born to smoking mothers. So smoking mothers with low birth weight makes this intersection have 18 members. Outside here, these are babies who are born to not smoking mothers. Over here, because all of the babies with low birth weight are in that set, then over here I have all babies who are born to non-smokers with a normal birth weight. So I have 186 members in that set. Okay, let's go on to blood type. I have 3 different areas or sets for blood type: A, B, and the Rh positive factor. And I know a lot of you are thinking, well, what about O and the negative? Well, remember, if it's outside of the set, then it's not. So I have my Rh positive, so everything outside of here will be a negative. And here's all of the A's, and here's all of the B's, which means anything outside of there is an O. So let's go ahead and fill it in. Let's find all of the A's. Now notice, outside here in this A, I need an A, only an A, And if it's not in this set, then that means this is all of the A negatives. So what percentage of the population is A negative? 6%. Now over here, this overlap right here has A and B together, but it is not overlapping with the RH positive factor, so these are A, B negative. So an AB negative here is 1%. Here I have B's, no A's, no O's, and also outside of the RH positive. So this is all of the B negatives, and that is 2% of the population. Okay, let's come into this overlap. These are B's with a positive RH, so this is all of the B positives, or 10% of the population. Let's come over to this overlap just because this is all of the A's with a positive factor. So this is all of the A positives. Right here in this portion, A positive is 34% of population. In here, it doesn't give us an A or a B, it just says positive RH. That means it's not a part of the A and it's not a part of the B, which means it's O. O and a positive RH is O positive, or 37%. And now I come up here, this outside white portion is not a part of the A, it's not a part of the B, so it's O. It's also not a part of the RH positive, so these are all O negatives, or 6%. I seem to have forgotten to put a box for the intersection of all of them. We can hurry and make one. Insert text box. Actually, I'm just going to come up here, copy and paste this one. Copy, paste, get rid of my numbers, and insert an arrow that points to the intersection of all of them. All right, have you figured out what goes there yet? That is the overlap of A and B and of positive. So that's the A, B positive, or 4% of the population. 4%. There we go. Now we have gone through sets, Venn diagrams, filling in the sets, and even creating the Venn diagrams on your Microsoft Word, coming up by using SmartArt. All right, we'll see you for the next section.